Welcome back to our new class of AI, machine learning, data science, and big data analysis. The topic of this class is going to be distributions, which are normal, Poissons, and also binomial. And also, I'm going to cover everything that you need to know about hypothesis testing. So I have separated and prepared this class in a couple of sections so that it is easier for you to understand, and I'm going to give you out codes and also explanation so you can practice along with me and also understand the whole class. So make sure not to skip any part. Make sure you are connected to the internet and you have a stable internet connection. And without any further ado, let's open up PyCharm on our device. And if you're not using PyCharm, open up any of the IDE that you prefer using. So, as you can see on my screen, I have opened up PyCharm. So let's create a new project. There we go. Going to make sure to inherit the packages and also make available to all the projects. And over here, as we are working with the custom environment, it is going to start off from the basic, or let's say from ground zero. So let's press on create and wait for our virtual environment to create the interface in front of us. So just as you can see on my screen, I have opened up PyCharm, and also my project has been created. Now, first off, we're going to go through what is distributions. So when you are working with your data set and also you are preparing for machine learning or even AI or even data science, you have to understand distribution because this is also one of the foundation. Okay, so whenever you are going through the process of distribution, it is basically going to tell you how your data is going to spread and how it is going to behave based on the probability, based on the processing that you are doing, and also how you are preparing your data set to create your model. Now, you might think like, why is it going to be important and why is it the foundation of machine learning or even AI? So whenever you are distributing your data to find out how much it is spreading and how it is behaving, it basically helps you or the user to understand the probability and give you out the approximate value or the outcome. Now, in many algorithms such as machine learning or even in AI, what it basically does is that it assumes the data or it assumes the probability based on the history or whatever data it has already. So what it basically does is that it gives you out or assumes a probability of distribution, or let's say prediction of normal distribution. Okay, now the last thing that we need to know about this is going to be the Poisson and the binomial appearance. So what it basically does is that it takes up specific variables and also specific data set from your data, and then what it does is that it classifies your data in such a way so that it helps Python to, let's say, predict and also presume your data. Okay, now as we already learned about what is distribution and why is it important, you also have to understand about what is normal distribution, because there are two types. Now, when are you going to use the normal distribution? Whenever you are working with data set, there are going to be different types of data. Okay, and let's say when you have specific heights, weights, coordination, test score, then there is noise in the model. Then you also are working with feature scaling assumption and predicting those values. You are going to work with normal distribution, okay? Because that is going to give you out an approximate value. Now we're going to go through everything step by step, but first off, what I'm going to do is I'm going to create my CSV, okay? So first off, let's create our CSV file. Here I'm going to put in example underscore data.csv. Okay, let's ignore the extension There we go. Now the first things first, I'm going to work with my ID. Now here, I'm going to put in, let's say, 18 to 20 values, which is basically going to make it a lot more easier. So ID, I'm going to put in value, and also, let's say, department. First off, 1, let's say it is going to be 40 over here, and the group is going to be A. 2 is going to be somewhere around 51, and also, over here, it is going to be A. For 3, I'm going to put in, let's say, 48. It is also going to be the A group. Then I'm going to put in 4, let's say 59, group is A. 5, in the same way, we're just going to continue until I meet like my exact outcome or how much I exactly want. So here I'm going to put in A. For 6, I'm going to put in 71, A group. 7, I'm going to put in, let's say, 53, A group. 8 over here, I'm going to put in 55, and I'm going to put in A group. 9, I'm going to put in 91, also A group. Now after this, I'm going to work with my double digit, and I'm going to make sure to put everything in the B group. So let's say 57, B group. 11 is going to be 43, B group. 12, I'm going to put in 69, B group. 13 is going to be 70, also B group. 14, I'm going to put in 25, B group. 15 is going to be 91, B group. And I'm going to put in, let's say, 16 to be 81, B group. And 17, 65, B group. Okay, so there we go. We have 16 or 17 IDs. Now this is what we're going to use as the data. Now this data set is going to contain all of the columns, which are ID row number. Then we have value, which is the value or the attribute of the value. And then we have the department, or let's say the section, which is A or B. So whenever we want to, let's say, group wise or want to, let's say, sample the data, there are 2 types. So A sample and B sample, which basically makes it 2 sample data set. Let's say here I'm also going to make sure to put in B. Okay. Now, as we have our data set, now the next thing that I want to do is I want to load and check if the CSV is working or not. So first things first, let's put in a Python file. Let's say test data_CSV. Here, the first thing we want to do is we want to open up our terminal. Now, I'm going to make sure to install all the necessary modules and packages or libraries that I'm going to need in this class. So I'm going to type in pip install pandas matplotlib seaborn. I'm also going to need a couple of modules. Let's say I'm going to put in scipy. Then I'm going to also import in, let's say, scikit-learn. Also sklearn. Now let's install all of these modules first and wait for a bit until everything has been installed properly. You can see ignore the following version that requires a different Python version. It requires Python 3.12. Okay, there we go. We have all of these over here. Now we're going to check whichever one is working. So over here, I'm going to make sure to copy this. If it doesn't show up, so we're going to wait for a bit until the pip version has been updated. There we go, successfully uninstalled pip, the previous one, and it's going to install the latest one. So here I'm going to type in pip install matplotlib. Now let's wait for a bit until this one is also done. And I'm also going to install SciPy, which is going to be very important in this class. But make sure you are connected to the internet because it is going to require a couple of data that is going to be downloaded from the web. Okay? So just make sure you have a stable internet connection throughout the whole process. Now, after this is done, now we're going to type in pip install, and we're going to also install numpy. We're going to wait for a bit until this is done. So it is already there. Put in pip install scipy. Wait for a bit until this one is also installed, and you can see that it is going to download the necessary data. Now, the last thing that I want to install on my PC or inside this project is going to be stats model, because we are basically preparing our data and creating distribution so that we can create our machine learning model. Okay, so let's wait for a bit until this is done, and then we're going to install our last module or our Python library. Okay, there we go, installing collected packages, scipy. Okay, so there we go, this one is also done. Scipy is installed. Let's type in pip install stats models. Okay, this is exactly how you want to type in. Hit on enter. Now wait for a bit until this one is also downloaded on your device. Now a couple of things are going to be required or already installed, because obviously it is going to work with other type of modules or other libraries at the same time. Okay, so you have to keep that thing in mind, that we're going to be connecting all of those modules at the same time. And the last thing I want to check is that if pandas has been successfully installed. Even though you can see we have pandas over here, but I'm just going to run it one more time to get, let's say, another check if it is going to work or not. So just type in pip install pandas. If it shows your requirement already satisfied, then you are basically good to go. Okay, so first things first, let's type in over here. Let's say import pandas as PD. Now data frame equal pd dot read underscore CSV. Now here I'm going to put in the example data CSV, and I'm going to print out the data. Let's say df dot head, open up the parentheses, and here I'm going to make sure to get the basic statistics. So I'm going to type in print data frame. Let's say I want to get the value. So double quotation or single quotation, put in the exact keyword, value, and also I'm going to put in describe. In this way, it will give us the basic statistics. Run the program, and if it shows you off like this, then it means it is working properly. Okay, so as this is working properly, now we want to get into our basic, or let's say our normal distribution. So in our venv, I'm going to create another Python file. I'm going to name it just test, and I'm going to close this off, but we're going to need it later on. Okay, so just like I said, when you are working through the process of normal distribution, it works with specific or accurate data such as heights, weights, coordinates, test score, noise, and even assumptions of scaling features. So first things first, you want to import numpy as np. Then I'm going to also import another module, import matplotlib.pyplot as plt. Now here I'm going to work with scipy.stats. I'm going to import norm. Okay, now in this way we will be able to work with normal distribution, and also we can work with deviations. Okay, so first off, I want to generate my data, but I'm going to be using them as a variable. Let's say mu. Now mu, this is what I mean over here, is a mean value. You can also put in me. Me equal, let's say 51. Then I'm going to put in the sigma value. Now you might be able to work with this over here, but I don't want any specific variables. Let's say sigma 1. Sigma 1 is going to be having a standard deviation. Let's say in this case 11. And here I'm going to put in 55 in this case. Okay? Now, the next thing that I want to do is work with the axis. So x is going to be equal n he, which is, as you can see over here, which is going to work with numpy. Now I'm going to put in the linspace. So me is going to be minus, so let's say 4 into sigma 1, and then comma, and then I'm going to put in me plus, I'm going to put in 4 into, let's say, sigma 1, and after that put in the number of tries it is going to do. So most of the time there are 1000 times I try to create my model, so I'm going to make sure to run them 1000 times again. Now, the next thing that I want to do is I'm going to work with the normal PDF. Okay? So the normal PDF is going to be on the y-axis. So y is going to be equal to norm dot PDF. As you can see, open up the parentheses. First off, I'm going to put in the x value, comma, the me value, and also the sigma value. Okay? So this is basically going to make your function a bit more dense on the probability. Now, as I want to visualize the data, let's say I'm just going to make sure to use plot. So plt.plot, x-axis and also the y-axis. plt.title. Let's say here I'm going to put in normal distribution of the me and sigma 1 value. Okay, so we have these values over here. Now another thing that I can do is that mean value is going to be equal to 55, comma, and also the standard STD-DEV standard deviation is going to be, let's say, 11 in this case. I can also put in STD just in this case. In this case, it will work too. After this, I'm going to work with the labels. So plt.xLabel is going to have, let's say, the value of the data or the value of the ID. plt.ylabel is basically going to have the distribution. So density of the probability. There we go. Now after that, I'm going to make sure everything is on the grid. So plt.grid, and here I'm going to make sure to put in the Boolean value true. And as I want to visualize it, I'm going to put in show, and that's it. So when you basically put in the norm.pdf, what it does is that it gives you the curve of the normal distribution. So when I run the program, this is going to how it might show up. There we go. So we have the normal distribution of me and sigma value, mean 55, and standard deviation is 11. There we go. This is how it works. Okay? So the data lies mostly within, let's say, 68% over here, or maybe somewhere around like 55, or let's say, yeah, something around like 45 to, up to 70 or 65%. Okay? So this is basically how you work with normal distribution. Now, let's move into the binomial distribution. So in binomial distribution, what you basically work with is the binary outcomes. Okay? And you also have to keep in mind that there is a specific format to work with binomial distribution. Okay? So the most important thing is that you have specific variables, and that is a specific value. One is going to work with the number of trials or how many times you want to run or test. And also, you're going to have another value, which is basically going to determine the success of your probability. So, how are you going to work with it? Okay, so first things first, what I'm going to do is I'm going to create another Python file. Let's say test1. Okay, so here I'm going to put in from scipy.stats. I'm going to import binomial. I'm going to import numpy as np. I'm going to import matplotlib.pyplot as plt. So just like I said, you're going to have specific variables. So another thing you have to understand is where are you going to work with the binomial distribution. You're only going to use binomial distribution when you have to predict, let's say, win or lose, pass or fail, 1 or 0. So you have seen this in my previous class that I've told you in couple of sports, what it does is that it gives you out a stat of the winning rate or the losing rate of specific team. So this is exactly where it can be used, okay? But it is going to use the data set and the history of that specific team, and then it is going to predict out the data. Okay, so first things first, over here, I'm going to work with n. So n is going to basically, represent the number of trials. Let's say I want 11 trials. And also, we have p. So p is the success of the probability, or the rate of the success of probability. Let's say the rate of the success of probability is 0.4. Now I'm going to work with my axis. X is going to be np dot arrange. So first off, 0, also n plus 1. So it increments 1 by 1. Y equal, I'm going to put in binomial dot pmf. And then you're going to work with x, comma, n, comma, and p. Now here, as we want binary output, so we're going to work with bar chart. So plt dot bar x, comma, y. So both of them are validated. Now plt dot title. Here I'm going to put in binomial distribution of, let's say, n and p. I'm just going to make sure to put it like this. Now after this, I'm going to put in the labels. pltx label, parentheses, let's say on the x label, success rate. And also plt dot y label is going to have the rate of, let's say, probability. After this, I'm going to put in plt dot show, and that's it. Run the program, and you will see this is exactly how it will show up. So as you can see, based on the data, when the number gets to 4 and in between 5, that is the amount, or that is the success rate to be the highest. When it is 10 and when it is close to 0, that is when the success rate is the lowest. So as it goes to the middle of the data, that is where there is the density of probability and the success is the highest. Okay, so that is basically how you can work with binomial distribution. Now, let's get into the Poisson distribution. So when we want to work with Poisson distribution, when you have specific events and it is going to happen at a fixed time, such as you want to send in messages, emails, or even notification on specific time, such as, let's say, customer support, when they're going to get the calls, when they're going to get the emails, when a person is going to arrive at any specific, let's say, reservation, maybe even at a hospital. So everything that is derived and given at any specific time, let's say something like when the clock hits 12 o'clock on December 31st, it gives you out a notification on every phone, Happy New Year. So that is exactly the type of thing when you want to use the Poisson distribution. Now, there are specific parameters of using Poisson distribution. When you are working with Poisson distribution, it basically works with the lambda. So a lambda is going to arrange the events per the interval based on the clock. Okay, so it already has the knowledge and program of its own and has its own memory. So how you want to work with it, I'm going to show it to you. First off, let's open up another Python file. Let's say test2. Here, I'm going to put in from scipy.stats. I'm going to import, I'm going to type in Poisson. Now, as the parameter is a lambda, so you cannot use any specific variables. You have to put in lambda, just like this. Just type in lam. Here, I'm going to make sure to work with, let's say, 5 intervals. Now, I'm going to put in the axis, let's say np.arrange. Here, I'm going to work with 0, and the exclusive number is going to be 16. Then I'm going to put in y-axis, let's say Poisson.pmf. I'm going to put in x, comma, and lambda, which is basically the variable. Okay, now plt.bar x, comma, y. plt.title. Let's say this is going to be distribution of Poisson. Then I'm going to work with the labels, plt.xlabel, xlabel. Let's say here, I'm going to put in events per, let's say, interval, and also plt.ylabel. Here, I'm going to put in, let's say, density of probability. So I'm going to put in plt.show. That's all. And now you want to run the program. Whenever you run the program, it might show you off as an error. If it shows you off as an error, it is completely fine. You can see we have NP. So here, we also want to put in import numpy as np. Okay, now run the program again and check if it is working or not. If there is plt, here I'm going to put in import matplotlib dot pyplot as plt. Now run the program again. If it shows you up this type of data, then you can see it is working. And that is the distribution of Poisson. So that is the exact amount of time, or at the exact time when the notification, the message, or the email is going to be sent. Okay? And that is exactly when or on which time it will be sent and how much or how many people it is going to reach. Okay? So that is going to be it. Now, the last thing that we are going to learn about in this class is going to be the hypothesis testing. Now, there are going to be two types of testing. One is going to be one sample, and the second one is going to be two sample. Now, I'm going to make sure to keep it very simple. First off, we have to understand what is hypothesis testing. So, hypothesis testing is basically done when you basically want to, let's say, claim that any data is statistically true, but it goes through decisions and also conditions. So, there are specific steps of hypothesis testing, such as null hypothesis, then there is alternative hypothesis, then there is significance level, the running the test, which is getting the p-value, and also you have to reject HO, which is p lesser than alpha. Now, p basically is going to give you out the test result, okay, which is basically the probability. So, I'm going to create more Python file over here. Let's say I'm going to put in, let's say, one sample. Okay, so over here, as we want to work with one sample, so there's going to be specific data and there's going to be specific values. I'm going to create the data over here, but you can work with it later on. Okay, so first off, I'm going to put in from scipy.stats. I'm going to import the test, let's say one sample. Now you might think, why is it not appearing up? It will not, don't worry. I'm going to put in sample equal. Now this is exactly where you want to put in your data. 38, 41, 53, or 54. Going to put in, let's say, 50. Then I'm going to put in 61. Then I'm going to put in, let's say, 49 at the end. Now, the next thing that I want to do is I want to get the average value. So here I'm going to put in p mean. So p mean is going to be closer to 50. So here I'm going to put in t stat underscore, and also I'm going to put in p underscore value. Okay, it's going to be equal to, let's say, t test 1 or test 1, just like this. You can also put in t test like this. T test 1 sample, and I can also put the exact same thing. So we have this over here. Instead of that, let's say t test sample 1. I'm going to put in the exact sample that we are working with, and also I'm going to put in the p mean value. Now after that, we want to print out specific statistics. So let's say double quotation, let's say t stats, comma, I'm going to put in t stat over here. Also at the same time, I'm going to make sure to put in a colon so it just distributes better. Going to put in print, let's say over here, probability dot value, comma. Here I'm going to put in p underscore value. After that, I'm going to put in if p value or p mean, whichever data you are working with. So we have p mean, and we have this p value over here, which is basically placed over here. So p mean is going to be lesser than a specific float value, such as, let's say, 0.06. So if this value is lesser than 0.06, I want to print out, let's say, reject H0. Now you might think, what is H0? So H0 is the null hypothesis. So basically means that I want to reject the no difference value. Reject H0 colon over here. And after this, I'm going to cut this off. I'm going to put in there is a significant difference in your data set. And if it doesn't meet up the criteria, else I want to print out, let's say, failed to reject H0. That's it. Okay, so I'm going to run the program. It might show you off as an error, but if it doesn't show you up as an error, it will give you out the t statistics and also the probability value. And it can say, or it is saying, failed to reject H0. Now, why is it showing you it is failing to reject H0? Is that the p-value or the p-mean value is a bit higher. Okay, now let's say I can work with 5. If I run the program again and check this, fail to reject H0, because this is basically not the mean value. The mean is going to be lesser than, let's say, close to 40 or 45. Okay, so if your p-value is lesser than 0.05, then the results are statistically significant. But if it is not, the results are not significant. Okay, let's say if I put in 45 and if I run the program, you can see fail to reject H0. Okay, so that means your data is not significant. And obviously this is a random data. So obviously when you are creating or preparing for your machine model or machine learning model, obviously you're going to be working with data which is going to make sense and is going to be significant. Now, as we're done with the first one, let's show you the last thing in this class, which is going to be 2 sample t-set. So how are you going to work with it? Let's create the last Python file that I'm going to show in this class. Let's say 2 sample. Okay, so here I'm going to put in from scipy dot stats. I'm going to import t-test. Let's say here I'm going to put in int. Okay, so let's say x is going to be equal, let's say 56, 61. Here I'm going to put in 59. I'm going to put in 63, and I'm going to put in 58. That's done. On the y-axis, I'm going to put in, let's say, 51. I'm going to put in 53. I'm going to put in, let's say, 50 over here. I'm going to put in 54. I'm going to put in, let's say, 52. So we have all of the data. So as we are working with 2 values, there's going to be t-stat. There we go. T underscore stat. And then I'm going to put in p underscore value. There we go. So it is going to be equal to t-test int. Now, as there are individual ones, one is going to be x, and the next value is going to be y. So I'm going to print out each and every one of them. So the first one is going to have the t statistics, comma. I'm going to put in the t-test or t-stat, and also for the p-value or the probability density, I'm going to put in probability value. Here, I'm going to put in p value just like this. You can cut this part out if you want to, but you can run the program just like this. And you will see we have the t statistics and also the probability value. Okay? So that is all for this class, and hope you understood about everything. If you are still facing any problem, or if there's any question, feel free to ask me anytime. I'm always there to help you out. Now, let's get to the summary. So what we have learned in this class is about normal, Poisson, and also binomial distribution. When are you going to use them in machine learning? How you can plot them and distribute them in Python. And also, we have learned about one sampling, two sampling, and also hypothesis testing by decision rule using the p-value and also t-stat. Okay, so without any further ado, let's move on to our next class of AI, machine learning, data science, and big data analysis.